today's course. So in this Tuesday, we talk about array, the array 1. So we introduce what is array and some for loops we can use to traverse array. Traverse, what I mean is that we can use the for loops to visit each element in the array. So that is what we introduce about array this Tuesday. And in today's lesson, we're gonna introduce the rest part of array. So the thing we will cover for today is first, I will talk about an important operator that we will use a lot with array, that is size of operator. And then I will talk about multi-dimensional array, because the array we saw in the last lesson is one-dimensional, right? 1D array, there's only one dimension. However, like I said in the last lesson, we can actually have multi-dimensional array. We can have 2D array, we can have 3D array, and if you like, you can have 100-dimensional array, but I believe that is not the thing you would like to write because it is very hard to understand for human beings. So, but again, I will talk about how to create multi-dimensional array in today's course. And then after the array 2, I will talk about something about how you can do to help you become a better programmer. That is the basic programming process and some debugging technique. So we'll talk about that in the rest half of today's course. And I believe I hope the thing we introduce here can help you survive the midterm exam, because you will definitely use a lot of debugging skill during the midterm exam. So let's start with the array first. And again, it's Slido time. So this Slido is, I just want to use this Slido to test if you guys understand what we introduced this Tuesday. So the question here is pretty simple, right? So we have an integer array A, and we provide an initializer after the declarations. And we say that if we have the initializer, we can actually skip the length of the array, because the compiler can know the length of the array based on the length of the initializer. So based on this initializer, what is the length of this array A? Okay, great, we already have 30 submissions. Let's wait until we reach 40 submissions. Okay, we have 40 already, so let's check out the results. Very good, so we almost reached 100% accuracy, but that's okay, it is high enough. So yes, the length of the array is 10, not 9. The reason is we actually start from 0 here. So how many numbers we have if we start from 0 to 9? We have 10 numbers. So that means that the length of the array needs to be 10, so that you will have 10 elements, so that we can store 10 numbers in the array. So let's check out the next slide. So here we have a simple program here, and your job is to think about what is the correct output of this program. And here I use a designated initializer to initialize array. So to get the correct answer, you need to know the meaning of the designated initializer and what is the initialized value of this array A. And again, let's wait until we have 40 submissions. Okay, let's check out the results. Oh, interesting. So over 60% of the submission choose the correct answer. And if you choose this one, that means that I get you in this program, okay? So if you read it carefully enough, you can see here I is not start from 0, it starts from 1. But the first element of the array is indexed from 0 to n minus to the length minus 1. So here, the value in the 0 element will not be printed out because here we start from 1 instead of 0. So this is the correct output of this program. And I also want to use this program to remind you, always remember the first element of the array is start from 0. I know it's a bit confusing. The first element start from 0, is not from 1. But anyway, all you need to know is that in C or in most of the programming language, if you have an array, it needs to start from 0 to n minus 1. So if you want to print out this information, the initial value for I need to be 0 instead of 1. Okay, very good. So let's start today's course. So what is size of operators? So what the size of operator can help us to do is that it will return an unsigned integer. So unsigned integer is the integer that don't have a negative value. So that is unsigned integer. And the meaning of this unsigned integer returned by size of operator represents the number of bytes required to store a value belonging to the type name. So the type name is the name of the type we put inside the parentheses of size of operator, and here is the general form of the size of operator. So we need to write the size of exactly as I showed it here, and then for the most of time we will add the parentheses here, and then if I want to note the size of a char value or the char object, I just write down size of parentheses and char, and the unit of the return number is in byte. So again, 8 bits equals to 1 byte. So in C use 1 byte to store any char value, including char variables. So if we write down something like this, it will return 1. But the size of other type may be different. For example, on the 32-bit machine, if you write down size of int, the return value is normally 4, because 4 is 4 bytes. Because 32-bit machine using 32-bit computer use 32-bit to store integer value. So that is why if we write down size of int, we want to know the size of any integer type. The return value is 4. It is use 4 bytes to store integer value. And this size of operator can also be applied to constant and variable. So we can put the name of the type inside the parentheses of size of, but we can also put down the name of the variable inside the parentheses, or any constant value inside the parentheses. And the size of operator will check the type of this integer or constant and return the size that we need to use to store this type of that value. So that is why, in this case, let's assume it is a 32-bit machine, and we have two integer variable, I and j, and we have the initial value here. So if we put 1, the integer constant, in the size of, the return value will be 4, because for C, 1 have the type integer. It's an integer constant. And we can also put down the name of the variable I here. And because I is an integer variable, so the return value of this line will also be 4. And again, I can put down the expression here. And because it is an integer, it is an expression that will return integer value because I and j are both integer variable. So the return of this expression will have the type integer. So C again use 4 bytes to store integer in this machine. So the return value is 4. And the parenthesis is, I would say, important. So I will recommend to use parenthesis whenever you use size of operator. Because if you omit, if you skip the parenthesis, if you just write down the statement like this, C will interpret this statement as this expression. So it will compute the size of I first, and then add the value of j to the return value. So this is not what we get if we want to calculate the size of I plus j. And the type of size of expressions, the return value of size of is not an integer type. It have a spatial implementation defined type called size t. So size t is the type defined by the C standard library. And if you go deep into the C library, you can find this line. So this line, C use a type define to self-define this size t. And you can see the original type for size t is actually unsigned long int. So that is why when we want to print out the value returned by size of operator, for the most of the time we would like to use %d or %eu to display the value here. But the %zu is the most correct way. But it's the most correct way because it is an unsigned long int. So if you use the %d to print out the return value of the size of operator, you might get warning message. But for the most of the time, it is okay. So I will say just use the one you like, and just to know that %zu is the most appropriate way to print out the value with the type size t. So why I want to introduce the size of operator? Because we use size of operator a lot with array. Because size of operator can help us to determine the size of an array in byte. For example, if A is an array with a 10 integer with a length of 10, the size of A, if we just write down size of A, the value will be 40. And the reason is why each element in the integer array A is an integer, right? And each element, like the element we have here, is an integer variable. And C used 4 bytes, or in this example, we use 4 bytes to store one integer variable, right? So this integer array A have 10 elements. So we just multiply 10 by 4, so we can get 40. So the total size of this integer array A is 40, and the size of the single element in the array A, like A0 here, is 4, because this array has the type of integer. So now you should know to calculate, so we can use these two things, size of A0 here, to calculate the length of the array. So we just need to divide the total size of array A by the size of each element, like the array 0 here. Then we can know how many elements this array A will have. And this is very useful when we have a variable length array, or we have the array that we don't know the length, or it is good if we want to let our computer, our programs to calculate the length of the array by themselves, instead of just write down the exact numbers in our code. And these expressions, this size of A divided by size of A 0, is very useful in the for loop. This example is how we can modify the for loops, and this for loop, we showed it in the last lesson. We use it to clear array A by assigning 0 to each element of array A. And you can see, instead of write down 10 here directly, we can just write down this expression here. And one of the advantages about this revision is that these for loops don't have to be modified if the length of the array is changed. So if now I want to increase the size of array A from 10 to 20, if I just write down 10 here, I also need to change the value I put here. But if I use this expression, I don't need to change these expressions if I change the length of the array. So that is one of the biggest advantages of using size of to calculate the length of the array. So that is all about the size of operator and how to apply it with the array. Then the next topic I want to introduce is about the multi-dimensional array. So like I said at the beginning of this course, we have only seen the 1D, one-dimensional array in the previous example, but actually we can create multi-dimensional array. We can have 2D array, it's like this. We can even have a 3D array, it's like a cube here. So let's start from the 2D array right now. So actually, array can have any number of dimensions, just like I said, you can have 100D array. But the 2D array is one of the array that we see for the most of the time. So the 2D array, we can imagine 2D array just something like this. And in the mathematics, we will call it matrix. And I believe if you guys graduate from senior high school, you will learn about the concept of matrix, yes? So this is a matrix here. So matrix is actually a 2D array in C. We can use 2D array in C to represent matrix. So in this case, we have the matrix. We have a 2D array, and the name of this 2D array is n. And here we declare array like this. We have 5 and 9. So what is the meaning of 5 and 9 in this case? So for C, 5 represents the number of rows this array will have. 9 represents the number of columns this matrix, this 2D array has. And both row and columns in the 2D array are indexed from 0 to its length minus 1. So you can see the value I put here is the index number. So it's from 0, 0, 1, 2, 3, 4. So there's 5 value here. So the number of the rows, the length of the row for this 2D array m is 5. And for the number of column, it's from 0 to 8. So there is 9 number here, right? So the length of the columns for this 2D array n is 9. And I can understand that sometimes it will be hard to remember whether the row is the horizontal line or the column is the horizontal line. So this, I struggle this a lot. And I also struggle this a lot when we use Chinese, like Han, Lan, Li. It's very hard to remember, right? I believe most of you have the same feeling here. So I want to kind of share my small tips that help me to remember the row is the horizontal one and the column is the vertical one. So let's talk about how to remember column is the vertical one. So you can see we have an L here. So L is the vertical line, right? So for me, I just remember, okay, the one that have a L here is for the vertical line. So that is the easy one. And for the roll, for me, I just remembered, I'm not sure whether you guys, you know, a kind of dessert. It's called Swiss roll, 瑞士卷. Yeah, so it's kind of like a famous brand in Taiwan. It's called 雅尼克. It's very good. Okay, that's another topic here. Yeah. So actually, there's no Swiss roll outside Taiwan. Swiss roll is not originally from Switzerland, because I've been to Switzerland, there's no Swiss roll, okay? But never mind, we have a Swiss roll, 瑞士卷 in Taiwan. And Swiss roll is a vertical cake. It's a horizontal cake, right? It's a big line of the cake. So I will remember, okay, Swiss roll is look like this, and roll have the same pronunciation as a roll. So roll is the horizontal line. Yeah, so that is the two way I use to help me to remember. Row is a horizontal line, and column is the vertical line. Okay, I think it's easier to remember than Chinese. Okay. So let's continue. So after knowing, so the first number we have is row. The second number we have in the declaration is column. So to access the element of n in row I and column j, we must write down this indexing format, n, I, and j. And I and j need to put inside the square bracket here. So again, it is not n, I, and j. It's n, and then two square brackets to separate I and j. Because this format is similar with the format we use in the mathematics. So remember, that is for the mathematics, that's for the math. For the C, we need to write down this format. So let's check out how we can change the number of I and j to get different elements in this 2D array n. For example, if we have n, 0, 1, what we need to do is to check out, okay, 0 is for row, so row is horizontal, right? So I need to start from the horizontal here, the 0 row. Then we have the column number 1. So the column number 1 is here. So the element I get by n, 0, 1 is this element here. And then if I change the number to 4, 7 here, all I need to do is to count from 0 to 4 for the row. So this is the 4th row. And then it's at the 7th column. So 0, 1, 2, 3, 4, 5, 6, 7. So this is the elements I can get using this expression, n, 4, 7. So yeah, so I will encourage you to practice this a lot and try to change the number of I and j and try to just count each row and column one by one, so you will have a more sense about which elements I can get based on different index combination. So although in this slide we visualize the 2D array as a table or matrix, but that is actually not the way they are stored inside computer memory. In a computer memory, or C, it's designed to store array in the row major order. So what's the meaning of the row major order? So it means that it will save one row after another row. So this is what the 2D array look like in a computer memory if you use C. So the first row, row 0, will be saved first. And then you will start from the row 1, then we will connect by row 1, and then row 2, finally the row 4. So the 2D matrix will actually store in the horizontal line, and one row after the other row. But we don't really, I will say we don't really, you need to have the concept here, but when you use the 2D array in C, you can still use this image in your brain to understand which element I can get in this 2D array. So how to access each element in this 2D array? So for 1D array, we only need to use one for loop, right? So for 2D array, all we need to do is to have two for loops. So we can have a nested for loops to process the 2D array or multi-dimensional arrays. And here is the example of how we can initialize an array as an identity matrix. So in case you forgot what is identity matrix, here's the example here. I believe you guys still remember we have this kind of special matrix in mathematics, right? So identity matrix is kind of like this. So for 2 by 2 identity matrix, only the elements in the horizontal line have the value 1, and the other element will have the value 0. So for the 3 by 3 identity matrix, only these 3 elements have the value 1, and the other element will have the value 0. And one of the important things for the elements on the diagonal line is that for these elements, the number of row and column is the same, okay? So this element is 0, 0. This element is 1, 1. This element is 2, 2. So by knowing this, we now know how to use these two for loops to initialize the elements on the diagonal line. So what we need to do is to use the first for loops to traverse each row, the second for loops to traverse each column. Then inside the loop body, what I need to do is to tell whether the number of rows is equal to column for the current element. If it is true, I will assign 1. If it is false, I will assign 0. Okay. So the next thing is about, we can definitely initialize or assign the value to the 2D array using these two for loops. But C also provides another way to initialize 2D array, that is initializer. So this is the initializer for the 2D array here. And you can see the initializer of the 2D array is the combination of one-dimensional array, right? Because each row in the 2D array is one-dimensional array. So we just write down multiple dimensional 1D array to initialize the 2D array. And the initializer for the higher dimensional array, like 3D array, 4D array, are constructed in the same way. And C also provides different way for us to shorten these initializers, because you can see if we want to use initializer to initialize every element in the 2D array, it's a big initializer. So here are some different ways that can help us to write down the shorter initializer. So the first rule about the initializer for the multidimensional array is that if the initializer are not large, it isn't large enough to fill the entire 2D array, the remaining element of the 2D array will have a default value 0. So let's check out the example here. So in this example, we have the same 2D array M, but you can check out in the initializer here. I only provide the initializer for the first 3 rows, right? So what will happen here is that only the first 3 rows of N will be initialized. So here I use the red rectangle to highlight the elements that will be initialized, and I use the blue rectangle to highlight the row that will have the default value 0. So you can see in this case, this element will have the initialized value we provided here, but the rest row will have the default value 0. And we can even shorter this initializer. So this is another version of the initializer. So if the inner list, or if the initializer for each row is not long enough to fill an entire row, the remaining element in the row will also be initialized to 0. So in this case, I only provide the first 3 elements for the first 3 rows. So only this part of the element will have the initialized value here. The rest of the element here will have the default value 0. Okay. And again, we have this traditional way to initialize a 2D array. We also have the designated way to initialize 2D array. So here's a quick exercise here. So we want to use this designated initializer to create a 2x2 identity matrix N. So if I want to do that, what kind of the designated initializer I need to write? Okay, I have the answer in the next slide, but here I just want to challenge you. You can challenge yourself whether you can think about what kind of the 2D designated initializer I should write down here. And you can write down here by yourself, or you can have the answer in your brain, and then you can jump to the next slide to check out if your answer is correct or not. Okay, I believe all of you are very smart, so I'll just show you the answer. So the answer is here. So yes, if you get it right, congratulations. And if you get it wrong, don't worry about it. You just need to remember the syntax of the 2D initializer, designated initializer. So again, I also use the same indexing style here to represent the designator. And then I just assign the initialized value to the elements indicated by the designator. So here I have 0, 0 here and 1, 1 here. I assign 1 to these 2 elements to create this 2x2 identity matrix. Okay, so let's take a short break. So please come back here after 5 minutes.